right, folks, welcome back. In this lesson, we're going to look at Chapter 2.2. It's using the tangent ratio to calculate lengths. So in the previous lesson, in 2.1, what we did was we used the tangent ratio. We were calculating angles. And in this one, you're going to notice you're given an angle and you're given a side. So you're going to have to figure out a different side. So this is when, given an angle and a side, and your goal is to find another side. Find another side. All right. Here it says determine the length of xy. Now this is a line segment, and the line segment is from this point x to this point y. So it's along here that we have to figure out what that measure is. Now we notice here that we have this angle, which is a 70-degree angle. So we're going to label our triangle accordingly. So if we go across here, this is going to be our opposite side. Okay, and this one here, this is our adjacent side. So just label that. Now, since we have adjacent and opposite, we know we're going to use the tan function. So we have tan theta equals opposite over adjacent. And now let's fill in the numbers that we have and fill in what we don't know. So tan of 70 degrees is equal to line segment xy. We don't know the value of that. We do know the value of the adjacent side, which is 5.0 centimeters. So now we have to solve for xy. We have to isolate this line segment. So we're going to take 5, and in order to, since it's being divided by the xy, we need to multiply 5 on both sides. So we're going to multiply 5 and multiply 5 on both sides, this 5 and that 5, reduced to 1. So what we're left with is xy is equal to 5 times tan 70 degrees. Now you have to remember that tan 70 degrees is a number, and the value of that number is approximately, let's see, I need a calculator. It's approximately, so if we go 70, tan 70 degrees equals, that's 2.7477 and so on, right? Now we're going to take that number and we multiply that by 5. You could put all of that in your calculator together by going 5 times and then tan 70. Just make sure you have your brackets in the proper space, okay? And then finally we're going to round it to 1 decimal place because it says 1/10 of a centimeter. So right here that says 1/10, so that means 1 decimal place. Okay, so this is 2.747. You don't have to show this part right here. What you do need to show is this line right here, and then at the end state that xy is equal to 13.7373 and so on, which when we round it is approximately 13.7 centimeters long. Okay, so you need to make sure that you state the units, all right, because we need to know what you're talking about and what the units are. Is it a measure that you're finding, or, you know, is it a length or a distance? Is it height, a weight? In this case, it's mostly going to be lengths and angles, right? So let's move on to the next one. Here it says determine the length of Vx. So Vx is from here to here. So we follow the path of the letters that we're given. And we are given this angle. So this side is going to be opposite, so because it's opposite to that angle. And this xv is going to be our adjacent. And our angle is 42 degrees. So we have tan of 42 degrees. That's equal to opposite over adjacent. So my opposite is 7.2. And my adjacent is the xv, or vx. I switched it around. So we're going to solve for xv. Now the way to isolate xv, it is one thing, okay? This is one this is one piece of our puzzle that we have to solve for. So we want to multiply both sides by the line segment x of e. All right, and then over here it's going to reduce to 1. And then we divide both sides by tan 42. Make sure you keep the tan 42 together. It's not going to be separated. All right, so it is a number on its, like, the value of it. So tan 42, for instance, is tan 42. It has that value, okay? So we want to keep that together. So we're going to take that and use it, simplify, write what we have left, 77.2, sorry, divided by tan 42 degrees. Type that into your calculator. When you do so, what you're going to be doing is pretty much this, 7.2 divided by, open a bracket, tan, and then most calculators open a bracket on its own for the whatever you put in that angle part. That's clearly the technical term for it. So let's do that and see what we end up getting. 7.2 divided by, and I'm going to put that in a bracket, tan 42, and I'm going to close my double bracket there. So we end up getting 7.9964. So 7.9964. All right, we need to round it to the nearest tenth, which means right here. So how do we round that? Well, this rounds to 8.0 centimeters long. Okay, next question. Our next question, and the last question in this lesson, it asks us to figure out, so read the last sentence and it tells you what you're looking for. How high is the tower to the nearest meter? So we're going to be figuring out the height. All right, I'm not the best artist, so let's see how I do. Let's call this my tower. Okay, that's a horrible tower. All right, so here it is. I've got a person standing in there, and what is this person doing? Well, at a horizontal distance of 200 meters from the base of the observation tower. So this is the base of the observation tower, and it's saying 200 meters from the base. So this distance right here is 200 meters. Okay, so what's happening next? The angle between the ground and the line of sight to the top of the tower is 8 degrees. So this is the line of sight. So see, this person is looking. That's going to be from where they're looking. The line of sight right here to the base. Let's see. Angle between the ground and the line of sight. So this is the ground, and this is the line of sight. So this is 8 degrees. Okay, what do we need to find? The height of the tower. So we need to find this height right here. Okay, so since we don't really have any labeling system for this, let's call this height, the height of the tower, let's call it x. So x is the height of the tower. Okay, so here, this is my degrees. So the height of the tower, that's going to be the opposite side. This is the hypotenuse, doesn't matter. And this is my 90 degree of my triangle. And this is my adjacent side. Okay, let's set up our tan ratio now. Tan of, so we've got 8 degrees, equals x, which is the height of the tower, over 200, which is the adjacent side. So now all we have to do is solve for x. Multiply 200 on both sides. Okay, and then we have x, that cancels with that, x equals 200 times tan 8 degrees. And figure that out, put that into our calculator. Make sure you're in degree mode. Okay, 200 times tan 8 equals 28.1081669. So x this equals 28.108169 forward, whatever, okay, dot, dot, dot. And we need to make sure that we round it. What do we round it to? Well, it says the nearest meter, okay, so I'm just going to move it up. It says the nearest meter, which means the whole number. So you're going to round it to the nearest whole number. Round to the nearest whole number. Basically, that means we are going to have 28 meters as our final answer for the observation tower. All right, there's your homework. Have fun.